What is humidity? Humidity is something we hear about daily in weather reports. Absolute humidity is the mass of water vapor divided by the mass of dry air in a volume of air at a given temperature. Relative humidity is the ratio of the current absolute humidity to the highest possible absolute humidity, which depends on the current air temperature. Humidity and human body. When the relative humidity is high, we feel much hotter than the actual temperature. If the relative humidity is low, we feel much cooler than the actual temperature because our sweat evaporates easily, cooling us off. The heat index is an index that combines air temperature and the relative humidity in an attempt to determine the human perceived equivalent temperature. People tend to feel most comfortable at a relative humidity of about 45%. Existing air-cooled chiller system. Air-cooled chillers are refrigeration systems used in both commercial and industrial facilities to cool fluids and/or dehumidify the air. They are used in a wide variety of settings, including hotels, corporate events, restaurants, sporting events, large-scale construction, industrial and manufacturing plants, and so forth. Large-capacity chillers extend up to a maximum of 6,000 tons in one unit and correspond to the heat source for district heating and cooling systems. Application: all types of vac comfort cooling applications. Supplemental cooling. Emergency response. Industrial, specific operating conditions. Food processing. Ice rinks. Process cooling. Cold storage, warehousing. Refinery and chemical production projects. Scheduled outages and turnaround projects. Testing requirements. Standby services air-cooled chiller. Heat. A form of energy. It flows from higher temperature to lower temperature. Refrigerator system. Removes heat from where it's not needed. Chiller. Heating, ventilation, and air conditioning, HVAC, equipment which acts as the source of cooling. Air-cooled chiller. How it works.
A typical retail outlet benefits from customers spending prolonged time browsing within their stores, and therefore spending more money. To encourage and increase customers' shopping periods, it is important that a comfortable environment can be maintained. From an organizational point of view, it is in today's market vital to ensure that buildings are managed efficiently. The Samurai Chiller exceeds expectations in meeting these needs. The fully modulating units provide chilled water to air handling units, serving a variable volume system or a fan coil system that provides a conditioned air to various areas of a store, from one level to multiple story. A central control system adjusts chilled water flow to match the requirements of the conditioned spaces. In addition to the modulating control, the efficiency of the Samurai is also enhanced by the use of split-fin type condensers matched with internally grooved tubes, providing high performance with the minimum footprint. The units, with their combination of inherently quiet Hitachi screw compressors, a double case design, and the rubber anti-vibration mountings, facilitate impressively low noise and vibration levels, allowing discrete installation and operation even when roof-mounted.
There is four main component which exists in both air-cooled and water-cooled chiller: compressor, condenser, evaporator, expansion valve. This is figure main part of the air-cooled chiller system. Compressor. The compressor lowers the pressure of the refrigerant in the evaporator so that it boils, and raises the temperature and pressure of the refrigerant gas. It also circulates the refrigerant in the system. Condenser. The condenser transfers heat from the refrigerant to the outdoor cooling medium, air or water, condenses the refrigerant, changing it from a gas to a liquid. Evaporator. The condenser transfer heat from the refrigerant to the outdoor cooling medium, air or water, condenses the refrigerant, changing it from a gas to a liquid. Expansion valve. The expansion valve drops the pressure of the refrigerant liquid from high to low pressure. This separates the high and low pressure sides of the system. Process flow air-cooled chiller.
The compressor takes the low-pressure vapor from the evaporator and compresses it into high-pressure vapor. The pressurization raises the saturation temperature, allowing the vapor to be condensed at a higher temperature. The condenser, a heat transfer device, removes the heat that has been added to the refrigerant in the evaporator and the heat of compression by transferring the heat to a medium which is lower in temperature, such as air or water. The expansion valve performs two functions. It controls the flow of the liquid refrigerant between the condenser and the evaporator, while dropping the high-pressure refrigerant to a lower pressure used in the evaporator. The evaporator, which is a heat transfer device, allows the low-pressure liquid refrigerant to absorb heat from the indoor air, changing the refrigerant into a vapor. In an air-cooled system, unlike a water-cooled one, a fan creates the movement of air across the heat transfer coil. The heat transfer process changes the refrigerant from a hot vapor into a cooler liquid in the condensing coil. Here is a diagram of the inner workings of an air-cooled chiller system. You can see the air-cooled chiller locations from this view, and also where the air handling units are. The pump circulates chilled water from the evaporator to the air handling unit. We will talk a bit more about air handling units in the water-cooled chiller section. Air-cooled chiller maintenance. Air-cooled maintenance is not complex and usually limited to regular lubrication of the fan and motor bearings and the cleaning of coils. However, These units are usually on the roof of a building, so they may be difficult to reach, which can inhibit regular maintenance.
Advantages of the air-cooled chiller. Install cost is generally lower. Less maintenance depending on the application. No need for a mechanical room. Cooling tower no needed. Condenser pumps not required. Disadvantages of the air-cooled chiller. Generally less efficient. Lifespan is not as long. Usually, had more operating noise. Motivation. Low humidity causes respiratory illness or certain allergies, breathing problems, and may cause joint pain. On the other hand, high humidity encourages bacteria, mold, and fungus growth. To design such a system which can work at relative humidity levels and maintain optimum range of humidity. To overcome the defects in existing system. The problem statement of the air-cooled system. To design energy-efficient device which when connected to an existing cooler system controls the cooling effect based on the variation of humidity. The product should be economical in hardware realization and efficient in power saving. Thank you for watching our presentation and have a nice day.